Hello, everyone. Welcome to my presentation on my research. And the title of my presentation is An Immersive Virtual Environment for Automotive Security Exploration. So, over the years, automation in vehicles has been on the rise. That is, the majority of the mechanical components of vehicles have been replaced by electrical components. This has led to the susceptibility of these vehicles to various forms of cyber attacks. Um, these attacks can cause various accidents and various infrastructural failures in the system. And one issue that we are facing is the limited awareness for the need of cybersecurity against various stakeholders. That is, there's lack of valuable knowledge about cybersecurity for in regards like understanding how to protect or defend the vehicles against those various forms of attacks. This paper addresses this problem by developing an immersive exploration platform that allows the exploration for the security of vehicular agents. That is, it enables the user to comprehend attacks on autonomous automotive systems. And in this research, we are basically focusing on range sensor attacks. That is, we are going to use we're going to use a VR infrastructure to play with various cyber security breaches, such as the range sensor attacks, while simulating the operational system in the real world. What are the research challenges we are going to face when building this? Some of the research challenges we faced while building this system is that we needed to create a natural setting in which a user can explore various attacks and its impact more precisely. And also, the environment must faithfully simulate like real world scenarios in the VR settings. And to face these challenges, our answer to this challenge was to carefully design some scenarios that that are very, very close to a real life scenario, and a scenario in which the user acts as an attacker of the system of the autonomous vehicle, but he is also a passenger in the autonomous vehicle, as seen in the image below. So what is the structure of our design? So our system was designed using Unity 2D, 3D, and the system was built using a VR asset. That is, we use the Oculus VR asset as a hardware for this platform. Our system is divided into three major parts. The GUI backend, and the GUI backend is responsible for allowing users to design and engage with the various unique attack scenarios through a user interface. And the users can select various attack parameters through the GUI, and then this is sent to the environment generator. The environment generator is responsible for generating multiple attack scenarios based on the attack parameters chosen by the user. And in the environment, we also have an attack equipment controller, which might include various virtual equipment we are using to simulate the attack, such as a virtual jamming device that would help us to simulate the noise produced by a jamming device in real life. So in order to make this platform intuitive to the users, we created a intuitive interface panel with knobs and sliders to control the various virtual attack equipments in the environment, as seen on the picture in the slide. As you can see, the user is using the Oculus controllers to control the various sliders and the various knobs. And yet users can experiment with various attacks, tweaking the parameters, and getting instant feedbacks on the attacks. And yet this allows the user to get a deeper understanding of the various attack scenarios, and it helps me understand the various countermeasures that can be performed to prevent those attacks. So after the next step we did was to conduct a user evaluation to determine the effectiveness of our platform to comprehend attacks and to various challenges to automotive security. And the step was like we conveyed the confidentiality guidelines to the users. They were asked to fill out an evaluation survey. They were instructed on how to utilize the Oculus VR software. We did a pre-training session for them. Then they performed the attacks, and we sent them a questionnaire, a link towards the evaluation survey in which they have to fill out to provide feedback on the platform use, realism, and effectiveness in simulating automotive security attacks. And in the scenarios, we have two scenarios in which the participant explored. That is the benign scenario in which no attack was performed, and the malicious scenario in which attacks were performed. As you can see from the video, in the benign scenario, we can see that no attack was initiated, and the vehicle moving towards the stop sign recognizes the stop sign and stops just in front of the stop sign. Then it moves and avoids an incoming vehicle because it stops in front of the stop sign. But in the other scenario, as you can see, the type of attack was chosen, which was the sensor tampering attack. And using the Oculus controller, the intensity of the jamming device, or the noise of the jamming device, was changed dynamically. As you can see, the attack was successfully implemented, and the vehicle ignored the stop sign and got into a crash instead. So what's our takeaway from this? So our results from the experiment show that the system scored high score in presence, immersion, and usability, and it indicated that the platform was successful in creating a realistic, engaging, and user-friendly platform for the participants. Although they gave some feedbacks that we should include more control and sensations like vibration to enhance immersion, which should be discussed in future development of the work. In the future work, we hope to extend this system for the exploration of more complex sensor attacks and to add various augmented reality features. We also hope to broaden the scope of our evaluation and expand our user sample by increasing the number of participants in the experiment. Thank you for listening.